Hello everybody, welcome to this webinar brought to you by Bursa Malaysia. This is Shane Chu tuning in from office here. Okay, not yet CMCO, so I'm still in my office. Okay, so today our topic is on overview in the semiconductor sector and the future technology trends. And today we have a very exciting session because the session is not oversubscribed. So many of you are expressed your keen interest to learn more about this technology sector. And today we have a very expert speaker in this segment to share with you about the semiconductor sector and also future technology trend. All right, so we are still have many of you logging in right now. So if you can hear what we are talking about, all right, if you can hear our voice, our audio, and our webcam, please type yes and tell us where you're tuning in from. Okay, awesome. Wow, someone say I'm very happy. Okay, obviously today is a very exciting sessions. All right, so all works well. So while we are waiting for others people to join in, so let me just state this disclaimer first. Whatever we share in this webinar is only for educational purpose. In no way that we give any recommendation to buy any tech stock or sell any tech stock. So if you decide to buy or sell any stock, you do it at your own risk. All right. So allow me to introduce our speaker. So he is also one of my teachers earlier on when I first learned about value investing. Okay, he is none other than David Poh. So an engineer by training, David began his career as an engineer in the telecommunication industry for 10 years before turning to his passion in value investing. So he served as a director in the local equities education and research firm for 3 years, managing research efforts and delivering advanced value investing and portfolio management education series. Thereafter, he stepped up to pursue his own aspiration, establishing the Spiral Thinker Group, a collaborative alliance to promote intelligent value investing and develop algorithm-based adaptive portfolio strategies for sustainable long-term wealth creation. Now, David is now a full-time investor and dedicates his time and resources to nurture the youth in financial literacy. So he's often invited to speak in brokers' seminars, webinars, as well as other Bursa-sponsored events, and his professional comments and opinions on value investing are often featured in business publications like Focus Malaysia. So David also provides consultancy services in value investing and advanced portfolio strategies for high net worth individuals. So if you want to connect with David, you can go to Facebook and find Financial Independence Express. So that's how you can connect with David. It is every time if I bump into any jargons in the technology sector, he is the guy that I will refer to, okay, because he really knows the tech sector as well as the telco sector inside out. Today he's going to impress with you with all his knowledge about the technology sector on Bursa Malaysia. Now, as you know, the tech sector has been always growing over the past couple of years, and it is one of the exciting sector that we often look at in the recent years. So today, let us hear from David Poh. David, are you ready?
Yes, Shane, I'm ready. Thanks.
All right, awesome. So let me make you a presenter, then you can take it away.
All right. Shane, can you see my screen in front of you?
Yes, I can see your screen.
Okay, great. Now, good evening, everyone. Thanks, Shane, again for inviting me to your Bursa Malaysia webinar series again. Before I start, please accept my apologies because about 10 minutes ago, I have an itchy hand syndrome moment where I accidentally clicked the broadcast button accidentally. So please forgive me for this mistake. Yeah. Now, as mentioned by Shane, today topic is very interesting, and I think this is something that a lot of investors in Malaysia are interested to know more about. I'll explain why that technology is very important. It's a very important sector in Malaysia along the way. So in front of you, this is the agenda or the content for my about slightly more than 1 hour presentation. So I split it up to a few parts for your understanding. Start with importance of semiconductor, the evolution of technology. Then we take a look a little bit about who are the major semiconductor players in the world. We take a look at the supply chain in general. Then we take a deeper look, detailed analysis into the supply chain of the semiconductor in KLSE. Then to wrap things up, I'm going to touch a little bit about the future trends in modern technology. Yeah. Now, perhaps before I go delve into details, first disclaimer, I'm going to talk a little bit about some of the listed companies in KLSE. So by no way this is a recommendation to buy, sell, or hold. This is purely for sharing and educational purposes. Now, the other thing is actually semiconductor sector is a really huge topic. So in order for me to compress everything to 60 minutes is kind of an impossible task. That is why I have to, I won't go into the details, but I'll give you a general overview as well as a framework for you to continue your, your own research and analysis into into this sector if you are interested. Then last but not least, the content as well as the research from this topic by all means did not come from myself alone. Actually, as mentioned by Shane just now, I have a team in a Spiral Thinker group who contributed a lot to the content of this topic. Yeah. So with that, let's get started. Now, I think it's quite apt, quite suitable for me to start with this slide to kick off the topic. This slide is to show you that in modern times data is the new oil. Okay, if you look at the chart on the picture on the infographic on the left, back in it compares who are the giants, the biggest listed companies in the world in 2005 and the latest one in 2020, and this is compiled by Statistica. Yeah. Now, back in 2005, about 15 years ago, now 15 years is not really a long time. You can see that the giants are, the General Electrics, the ExxonMobil, Microsoft, Citigroup, so on, Walmarts of the world. Now, flash forward to today, 2020, you see that number one, the height of the bar is very high now, meaning the market capitalization of these companies are much bigger than 15 years ago. That's one. And secondly, if you look at the names, we've got Apple, we've got Amazon, we've got Microsoft, Alphabet, which is another name for Google, Facebook, Alibaba, so on and so forth. The only non-tech company name in this list is actually Saudi Aramco, which was recently IPO as well. Now, this shows that actually this is indeed the age of tech giants, which means that if you are an investor, right, and especially if you have portfolios overseas, not just in Malaysia, you've got to have some of these these great companies in a portfolio, right? In fact, if you notice, since the COVID pandemic, the stocks that really drove the US indices up are none other than Apple, Amazon, Microsoft, so on and so forth. Yeah, but there is a problem when these tech giants become too big, in a way too big to fail. Now, many decades ago, oil was a highly regulated industry. Okay, there were a lot of laws and regulations, to regulate the industry as a whole. Now, the same thing is going to happen to tech as well. Loosely said, tech is not a very highly regulated industry for now, but things are changing already. As I think some of you may have known, that the U.S. Congress is actually they are coming up with an antitrust reform proposal to break out the big tech giants into smaller pieces. Yeah. So this is something that we will be keeping in track because we do see a lot of opportunities in this particular industry if this really does happen. Okay, now, so why is technology so important? Again, if you have listened to my webinars before, you know that I'm a sucker for history. That's why in fact, even for technology, there is a historical element. Now, The wave chart in front of you is called the conjunctive economic cycles. All right, it is discovered by this mathematician called Nikolai Kondrativ back in the 1930s. So in a way, he was to do. I mean, in summary, he was commissioned by the Russian government. All right, the start last time to look at what is the relation, or was there any relation between the economic cycles as well as technology advancement. All right, so the outcome of his study is that rather than explaining the cycles in the period of time, which is maybe 50, 60 years of cycle, Kondrativ said that actually should be characterized by technology advancement. All right, the conjunctive cycles, he called it K waves or long economic cycles, right? And each cycle ends. So this is one of the most important characteristic. Each cycle would end with a crisis. If you see the chart in front of you, since the 1800s, technology started with the steam engine. Before the steam engine came about, everything was done by hard labor, blood and sweat, human labor. Then the steam engine replaced a lot of this human labor and make things progress, make things more efficient, increase the productivity. Then from the steam engine, we have the the railway and the locomotive. Then from there is the age of the electrical engineering and chemical engineering. Now, fast forward to the 2000s, if you remember, something very big happened in 2000. Do you remember the dot-com bubble? Yeah. So that was the age where if your company has a .com in the name, right? Once you list the stock, the price will shoot up to the moon. It's a little bit like what is happening to our glove stocks these days. You know that because of the COVID pandemic, a lot of companies are saying, they are going to venture into gloves or vaccine distribution, so on and so forth. Then with this news, to drive the price, even to limit up, even face masks, has that ability to drive out the stock price. Then back to this conjunctive wave, as you know, dot-com bubble crashed, okay, and then what was left from this cycle is actually the tech giants that you saw, the Amazon, the Microsoft, the Google, and the Facebooks today. Now, then that is probably the fifth conjunctive wave. So what is the sixth conjunctive wave? A lot of people are saying that the sixth one will be circling around psychosocial health, which will include biotechnology, AI, and a lot of bioscience. Okay, and we don't know how long this cycle is going to last, but if you understand this chronology, you would know where to put your money in the future, right? So this is the basis of this slide. Now, so now that we saw the technology comes in cycles, and they are important, for the economic advancements as well. So what is at the heart of this technology is basically the semiconductor. The semiconductor, these modern semiconductor, it can be as tiny as a rice grain, or as small as your hair follicle. All right, but no matter which application the semiconductor you use, whether it's in transportation, military, aerospace, medical, datacom, telecommunications, automotive, consumer electronics like your iPhones, your gadgets, as well as the TVs, right? At the heart of it is this little semiconductor. Now, and this semiconductor, why is it useful? The most basic module is what is shown here. It's called the transistor. Now, if you have studied science in your high school, probably you know what this is about, right? So the transistor has a P as a positive junction, a negative junction, and a gate, and it is used to either allow or to stop signals from passing through, as well as energy. So semiconductors are very essential technology enablers that power many of the new devices, as well as the digital technologies we know today. And it's Spiral Thinker, we believe that technology as well as semiconductor has a long way to go. So much so that I understand that a lot of people opine that semiconductor or industry or technology industry is very cyclical. In a way, it's right. Okay, if you focus your time frame into a very specific period, But if you look at it on a long-term basis, example from this WSTS snapshot of the worldwide semiconductor revenue since 1996. So if you look at it around 25 or even more longer, right, you will see that actually the technology industry is a long-term on the uptrend. On this 25-year period, the growth is about 6% compounding annual growth rate. Yeah. So yes, along the way, in certain years, it may be down. It may be due to geopolitical issues. It may be down to economic cycles, so on and so forth. But on the long-term basis, semiconductor will keep on rising and will become more and more important to our life. Now, ask yourself, just a very simple idea. Compare the car that you have been for those of you who are driving. Compare your car that maybe you have bought it 10 years ago or 5 years ago, and imagine in the future you're going to get yourself a brand new car, say 10 years later. Do you think your future car will have more electronic components than your current car? Do you think it will have more exciting features like driverless system, superb infotainment systems compared to the conventional cars today? So what enables that? Is nothing but semiconductor. Yeah. So that's the importance of semiconductor on the long-term basis. Now, next one I'm going to talk about is the evolution of technology. We saw that technology actually affects economic cycles. We look at the heart of technology is actually semiconductor. Then we look at what are the high level or what are the errors that is driving the advancement of this technology. Now, in front of you is what I call the 3 errors of demand, which I took from VLSI research from the US. This paper was published back in 2018, so it's pretty old. It's about 2 years old, but still very relevant today. As you can see that on the left-hand side, in the 1960s, it was when the transistors start to came about. Before transistors, computers in a way were, those light bulbs. They call it the tubes, the vacuum tubes, which is used to compute logics, right? Then when transistors came about, which came from semiconductors, it revolutionized the age of computing, right? So between the 1960s to 80s, everything was all about computers. So in that period, the in thing to do is to build more and more powerful computers. Don't care about the size, don't care about, as long as you can compute more data in a shorter span of time, just build it. There was a picture which I didn't manage to show in this slide. Actually, the first memory, I think don't know how many bytes was as big as a cargo. Yeah. All right. So with so much computing power, being built and designed, right? Naturally, so it's a very natural progression. People would want to do with mobile. People don't want to drag their big machines along the way, with them along the way, right? They will prefer something which is more personal, which is more mobile, and hence the birth of the mobile-centric era, where where we have from the landline phones to become the not walkie-talkie, the taiko tai, which looks like as bigger than this water bottle, right? So those were the days when when the technology focused more on the mobility instead of the computing power. Okay, I don't know if you remember the old phones that we used to have had a very big bulky antenna. Then when they do without the antenna, I still remember my very first Sony Ericsson model, right? It was a huge thing. But today, this candy bar format, is very common already, and you can't even see where the antenna is. Okay, so that is the age of mobile centric. In fact, I think we are slowly transforming from a mobile centric technology era to what we call the data centric era. Now you see, with so many mobile devices which is being used being thrown around, right? These mobile devices will generate a lot of data. So how there'll be a lot of challenges coming up. How do you store the data? That's one. But more importantly, in an economic sense, how do you make use of this data to deliver a better, more advanced service, technology, or better services to your consumers? That is the essence of the data-centric era. All right, and this is where a lot of cloud computing or the connectivity will, as well as the data centers and memories, will play a very big role. Then this is where we hear about, other than that, we hear about blockchain, cognitive AI, so on and so forth, right? So if you can understand the natural progression of these technologies, right, you will know where to smell the money. You will know where to put your investment capital, right? So that is why I would recommend you guys to maybe take a deeper look. I have included the source here in front of you, so you can Google it. There's a paper on it, all right? Probably if you're interested to delve deeper into this topic, by all means, please study this paper, yeah? Now, so as I mentioned, with the explosion of data, right, actually everything is, is going to be connected to the internet. So I think a few years ago, when I was still working in Maxis, this new term called Internet of Things came about, and it was like the most exciting things that the telco engineers were talking about those days. Of course, back then it was predicted by 2020 there will be more than 50 billion things. So when I say things, it is not just devices, it is not just your smartphones or your watches. It's like everything from your smart meters to your TVs to your speakers to your your robot vacuum cleaners to your fridge, which is connected to the internet, and they coin this the Internet of Things. All right, and of course this has not really came true. I think it was backtracked for it was postponed for another few years. But whether it's happening today or 3 years or 5 years down the road, right, this is going to be happening. It is just an eventuality. 50 billion things will get connected, and after that there'll be more and more. It is an exponential effect, right? Now there is a very important effect that you have to see from here. You see, if I go back to the slide, right, now back in the days where 2G and 3G was the main connectivity, main technology, right, the focus is on the downlink, meaning what you download. Okay, so when I was an engineer in Maxis, when we do the link budget means how you want to apportion your bandwidth, your resources to balance, how many megabits per second you want to allow for the downlink, how many you want to allow for the uplink, so to speak, right? It was always in balance. Why? Because people were downloading more than uploading. But in the data-centric era where we have the explosion of Internet of Things, right, download and upload is equally important. Why? Now, unbeknownst to you, as long as you have a device, a smart device like this on, this device is always communicating to the internet, sending your GPS locations to Google Maps, for example, sending your push notification, sending your data, your serving, behavior, so on and so forth. You're uploading movies, uploading emails, and as well as downloading, right? So the importance of internet is big. The importance of the connectivity technology is getting more and more important. That is why 5G is going to be a very big thing in the coming years. So for this topic, I'm not going to talk too much about 5G. In fact, next month I'll be back again to talk specifically about what are the technologies around 5G and where we can invest our capital. Yeah. So for today, that's about it. Now, next, actually from here, right, how do we know what are the next technology to invest in, right? There are many ways for us to study this. So personally, I follow a lot of this company called Gartner. They are a very good research company. Every year, for example, on the right-hand side, they publish this thing called the Hype Cycle for Emerging Technologies. So they have a latest one, which is published for 2020. I'm going to talk a little bit more about this later towards the end, but for now, I want to focus on the left-hand side. This is a report. This was extracted from a report by Deloitte on the global semiconductors outlook. Basically, They say between the year 2017 to 2020, so a 5-year period, what are the emerging or modern technology that we can invest in that is enjoying which is expected to grow on an exponential basis. So on the top of the list, you can see head-mounted display, right, which is expected to grow at a CAGR of 34.9% per annum between 2017 and 22. Then head-mounted displays are like your Google Glass or your Oculus, all these virtual reality or augmented reality devices that you put in your, which is like a glass for you. Then other devices include the smartwatches, okay. Then more interestingly is the ADAS. ADAS is a advanced advanced driver assisted systems. So it is a step towards autonomous driving. Okay. Now don't know about you, but if you have seen some of the videos in Facebook about a Proton, the new Proton car that you can just stop the car and then just press a button, it will auto park by itself. So that is one form of ADAS. And ADAS technology is, has gained a lot of traction over the past few years and moving forward. So the Gartner believes that they are going to enjoy about 24% growth between to 2022. And in fact, I believe after that, it's going to have an even higher trajectory. Now, other than that, of course, we have other things like the EVs, like electric vehicles or hybrids. Personally, I am very interested in solid state lighting. So this is a very advanced LED. Okay, I'm very interested in automation as well, infotainment, so on and so forth, storage, so on and so forth. As you can see, right, technology is such a wide topic and so many areas, so many niche markets, so many niche technologies. It depends on where which segment of the technology you understand best and which you think has the biggest potential to grow, to give you the kind of profit, the kind of growth that you want to look for in a portfolio. Now, one of the ways how I look at this or how I decide which specific part of the technology to invest in is actually which I'm going to show you now. Now, this is a report by PwC, PricewaterhouseCoopers. Every year, they update their report on global semiconductor outlook. Now, I compiled this from two or three PwC reports that I got. Basically, I just concatenate, all the data that I can find between 2012 to the latest one. It may not be entirely accurate because I think they revised some of their forecasts as well as data, but that's not important. The most important thing is what does the trend tells you. Now, this chart shows you the global semiconductor billings and growth. So they're not just talking about technology. They just not talk about what they aspire to make. It is really, these are the numbers that are being built, manufactured and paid for, as well as the potential for forecasted growth. Okay, and the reason why I like PricewaterhouseCoopers is because they segmentize the billings into 5 different subsegments, namely the automotive, which is denoted in the gray chart, sorry, the gray bars here, communications, red, industrial electronics, the yellow, data processing, and consumer electronics. Yeah. As you can see, actually, the biggest chunk of these billings go into communications and data processing. So does it mean that, yep, that's going to be the segment that I'm going to invest in because they command the largest chunk? Is that really the only way? Well, it's not necessary. That's why we have to study the details, and I always believe the details is in the devil. Sorry, the devil is in the details. Pardon my English. So I took a step further and study what is the compounding annual growth rate for each of these segments, right? And I found out very interestingly, yes, although communications as well as data processing electronics command the biggest absolute billings in terms of US dollars, but their growth is the lowest. Of course, when you become so big, when your base is larger, in order to grow, right, it becomes more challenging. But when your base is smaller, for example, automotive, where the billings into 2020 is maybe forecast to be about 50 billion US dollar, but look at the growth the growth for automotive is expected close to 10% per annum for between 2019 to 2022. And then the second highest is actually the industrial electronics. Yeah. So this can give you a better idea of which of the technology segment that you want to put your money in later. Okay, and this is one of the ways that I do. You can find your own ways. But to me, this gives me another insight. Now, automotive and industrial electronics has one common component which I'm very interested in, which is power. Okay, now with more advanced electronic vehicles as well as more advanced industrial needs for power electronics, right? The power devices are becoming more and more important. All right, that's why a lot of investments are being poured into the power materials as well as the power transistors. And you'll be very happy to know that in Malaysia, there are many companies that focus on this particular segment, the power management. All right. So if you're interested, you can dig deeper into this. But later on, I'm going to show you guys maybe a couple of case studies of the companies listed in Malaysia in KSE that does this, right? Okay, now I'm going to go a little bit faster. Apologies, because I've got only 1 hour to cover such a vast topic. Okay, now next topic, so the next agenda, I want to cover the difference between technology or semiconductor as well as big tech. Now, the chart by global data in front of you shows the technology companies rank in market capitalization based in back in third quarter 2019. As you can see on the top of the list is Microsoft, Apple, Alphabet, Facebook, so on and so forth. But are these really they're called technology companies, but are they semiconductor companies? Well, actually they are not. Now, if I put things into a very simple comparison, basically there are two camps. One is a big tech and the other is a semicon. As you can see here, big tech are the names, the big names like Google, Apple, Facebook, Netflix, Amazon, which a lot of them are doing, platform or services companies, whereas the semicon companies are normally the hardware companies like Intel, Microsoft, Samsung, so on and so forth. All right, so my next slide will show you what are the biggest semiconductor companies in the world by revenue in the year 2020. I hope you can see clearly in front of you. If not, you can maybe have a look at the recorded version later. Now, on the top of the list is actually Samsung. Now, Samsung, although they are not a pure semiconductor company, in fact, they are a large conglomerate, but they are one of the actually, in fact, they are the biggest semiconductor company in the world with a total sales of more than 200 billion US dollars in 2020 forecast. Yeah, they are a Korean company. Then followed by Intel. These are the names that you're probably more familiar with, like TSMC. So what are the difference between these companies? Yeah. Now, in order to understand semiconductor companies, you've got to maybe know a little bit about what are the names. For example, have you heard of the word called foundry? Now, don't worry, it's very simple. If you have seen maybe movies like Lord of the Rings, or where ancient movies where they melt metal in a casing, and then they pour it out to make swords or steel tools, right? That is basically a foundry. In semiconductor, the foundry, instead of melting metal or other iron, what they do is they actually use silicon to make wafers, and in turn these wafers are turned into microchips, chips that will drive our electronic devices. Now that is a foundry. Now at the other end of the spectrum is what we call IDMs, which stand for independent device manufacturers, right? Now foundries, they produce the wafer, the ingots, the wafer to make the chips. The IDMs do not have this foundry. What they do is they design the circuits to make into the chips. So they may outsource the process, the manufacturing process, to pure foundry players like TSMC. Now, of course, TSMC is the biggest pure play foundry in the world, but they are not the only one. There are smaller companies like Global Foundries, UMC, Standard, SMIC, based in China, so on and so forth. Okay, so there's the difference between IDMs and foundries. IDMs are that do not, some IDMs have their own foundry facilities, but most IDMs do not have, and these are what we call the fabless IDMs. They do not have the fabrication. Fabless means fabricationless, all right? And these IDMs, they can be categorized into different segments as well based on the application. For example, Intel is all about data processing, consumer devices, computing, networking. Then we have very specific IDMs like SK Hynix and Micron Technology that specializes in memory. Then we've got the names like Qualcomm, Broadcom, Qorvo, Skyworks that focus on communications as well as consumer. All right. Then we have more rounded or hybrid companies like Texas Instruments that basically does everything under the sky. We got Toshiba, then we got NVIDIA that specializes in processing, especially graphical processing, so on and so forth. Now, these are the only 10 names biggest in the world, but there are hundreds and hundreds of other semiconductor companies, which you can just Google it by your own. Okay. Now, next, I want to talk a little bit about how semiconductor companies grow, in time. Right, so I'm going to use a slide from Broadcom, History of Innovation. Now, it is a very natural thing or very normal thing for semiconductors to grow inorganically, means that they will acquire, they will acquire to become bigger and bigger. For example, the Broadcom we know today, now Broadcom is a very huge name in communications. So when I talk about 5G topic next month, I'm going to focus a lot about Broadcom as well. Broadcom started from this company called Broadcom. Then HP came along. HP was, through a series of mergers and acquisitions with Agent Technology, they were bought over by Avagor. Then the IPO. Then they merged with Broadcom in 2016. But that period is more of a hardware play, so they were focusing a lot on hardware. But after 2016, you see this shift in the business model. Instead of focusing on hardware, they focus more on software or the application layer already. That is where, our dearest Hock Tan, right, his Penang, by the way, the founder, they started acquiring companies like Brocade, CA Technologies, and the latest acquisition was Symantec. Symantec is an antivirus and security system solution. So you can see that is how they grow. Now, one of the biggest catalysts for M&As, the mergers and acquisition, is to shorten or speed up the time to market of the services and products. So for example, if they were to do it on their own, it may take them 10 years to develop a technology and market it. So if they were to merge or collaborate or JV with another partner, right, they may shorten that time to market period much shorter. And this is one of the catalysts for them to grow, to merge. Now, the other catalyst is more of a competitive nature. Now, although this picture is not a semiconductor companies, they are basically telecommunications company, but it shows you that competition can also drive merger and acquisition, and it takes the weaker players, merge into one, merge with the bigger players so that they can be more competitive against the other players in the industry. For example, many years ago when I started out, there were Alcatel, Lucent, Siemens, Nokia, Motorola in the communication space. Those are the 2G days. Then when 3G, 4G came about, they slowly merged the industry to become a couple of players: Alcatel, Lucent, Nokia, Ericsson, and then which in turn later on, Alcatel and Nokia merged again to become the Nokia today. But as you can see, there's one guy that has been very, very steadfast along the way, it is Huawei. Of course, may argue that Huawei, of course, they had the backing of the Chinese government. That's why they can survive and thrive. Well, that is another topic for another day. But the reason why I share this with you today is to show you that, there are many different catalysts or incentives for the companies to merge or buy over one another. And you will continue to see this trend ongoing, in the future. Okay, so now next I'm going to delve a little bit deeper into the semiconductor process already. So bear with me, this can be a little bit technical, but I will do my best to make it as simple as possible. All right, now as I mentioned before, the first process of the chip making process, so I use the word chip as a very as a simple name for semiconductor. All right, The very first step is to get the raw material, which is the wafers, which is made from silicon, right? So of course, in Malaysia, we do not have any manufacturer that produces this. So basically, what they do is they produce the ingot, right, a silicon cylinder. Then they're gonna cut it into very thin slices called the wafers, all right, into this in a foundry, all right, and this is what we call the front end. So imagine the wafer like a piece of paper, and what they're going to do is going to print by laser. In the very layman's term, they're going to print by using. They're going to print the circuits into the wafer using laser technology. And after that, what they're going to do is going to cut that wafer into small pieces and put it into the IC packages, which is going to be installed in your electronic device. All right. Now, in order to do that, of course, we've got to have the support of the OSAT players. OSAT stands for Outsourced Semiconductor and Test Assembly Solutions. Basically, these are what we call the back-end system. So in semiconductor, the front end and the back end can be a little bit confusing because they are counterintuitive to what we normally use out of the semiconductor space. But in semiconductor, front end means the very beginning process and the back end means towards the consumer, the end product already. Okay, but along the way, there's a very important segment called the ATE, which stands for Automated Testing Equipment. I'll show you later that in every step of the semiconductor manufacturing process, you just got to test and test and test and test. Why? Because you cannot afford to, the objective is to minimize the defective chips which to go into production and be packaged into a semiconductor device. Can you imagine that if you have a faulty chip and you put it in your car and it is a driverless car, and can you imagine the potential hazard it's going to have, right? So of course, you talk about smartphones, it's no problem. It's spoiled, and just send it to the manufacturer to to repair. But when it comes to cars, it is actually life. It can cost life. So that is why each of these manufacturing process steps, it's got to be tested, and the defective parts need to be taken out of the entire production process. Okay, now I'm not going to talk too much about this. So basically, it's just another more detailed way of looking at the high level processes from wafer all the way to the assembly process and then the final test and inspection. Okay, more interesting is this chart. So as I mentioned just now, after the pattern or the circuits are printed to the wafer, so this is done by companies like TSMC. TSMC, as I mentioned earlier, is a pure foundry player. So they just tell the IDMs will give them the design, all right. Then based on their customers' demand or requirements, they'll see what kind of technology node, whether it's 10 nanometer or 15 nanometer or the latest 5 nanometers, right? Then they will imprint the circuits into the wafers. Then after that, these wafers are going to ship to the OSAT players, which may not be on the same island, same country. It may be shipped to another country. All right. Then the further processes will be like to dice the wafer. All right, after you dice the wafer, so imagine it's a very small thing, then you have to put it into an IC where you have to attach it. It's called a die. You attach it on the IC, then you have to connect the wire bonding. All right, then you encapsulate it into a package, and then you do have testing, and then only then you send out to the EMS players. EMS stands for Electronic Manufacturing Services, to assemble into your devices. Now, for example, one of the biggest things that you should know is actually Foxconn. Now, Foxconn is the one of the biggest assembler or EMS for Apple products. Yeah. Now, along the whole process, you can see that each process there is an arrow down, which is where you see the word AOI, right? Now, AOI stands for Automated Optical Inspection, which means that along the way, in each step, you have to inspect your product, the work in progress products along the way, and you have to pick up those that are defective and throw it away. Otherwise, it may go into the system and contaminate the supply chain. Okay, so there are a lot of players along this, but I want you to focus on the end part. Now, the end part, again, as I mentioned, is what we call the OSAT, the Outsourced Semiconductor and testing systems. Now, these are very important. You know why? Now, if let's say faults are found in the beginning process at the front end, right? You can throw it away and the cost is whether negligible or very minimal. But imagine along the way when you add more processes and then there is when it comes to the packaging part, then there is where a lot of errors happen, right? The cost, the economic cost to the supply is very, very high. That is why personally I like a lot the OSAT players, because OSAT players they are very serious in the business. And the most important thing is actually there are a lot of OSAT support companies in Malaysia. They are not the biggest, but they support the biggest players. Now, who are the biggest OSAT players shown in the next slide? Although this is an old statistics back in 2017, but they are pretty much the same today. Of course, a lot of them are Taiwanese, US, or even Japanese companies. For example, ASE Group and Spill, they are Taiwanese company. I think they merged back in 2018 to become the largest today. Then we've got companies like MCore and PTI Technologies, which are US-based, JSAT, Tianshui Huatian, Tongfu, so on and so forth. They are based in China. UTech is Singapore. I think Chipmos is Taiwanese as well. Yeah, so these are the biggest OSAT players in the world in the semiconductor supply chain. Then of course, how do we connect this information, this data, right, to Malaysia? Because at the end of the day, you want to know what are the companies in Malaysia that you can invest in, right? It's very simple, right? A lot of these companies have presence in Malaysia. Now you'll be wondering, hey, why Malaysia? Malaysia is actually a very interesting and important semiconductor player, which I will show next. Yeah, okay. Now I don't know how many of the audience tonight and do realize that semiconductor or electronics is actually the biggest contributor of our national GDP. A lot of people think that it is oil, but many years ago, actually Malaysia has become a net importer of oil. If you concatenate or if you consolidate the components which relate to semiconductor or electronics or machines, right? Actually, they are more than 40%. So which means that electronic products constitute more than 40% of our total export. Although this is a 2018 statistics, but they are pretty much the same today. Although here you see it's 35%, but of course there are other segments like this optical. Remember I talked about optical inspection systems, or there are 4 here, and then as well as some of the machines here. So all in all, they contribute about 40 or slightly more than 40% of our total exports. And electronics is a very, very important component of our national GDP from the manufacturing side. Yeah. So much so that they coined that E&E industry is the golden goose of Malaysia. So this is for Malaysia, but how does Malaysia stand in the world? You'll be very surprised as well. Based on the 2018 statistics of the global exporters of semiconductor devices in the world, of course, China remains the biggest at around 33% back in 2018. But after China, you see that the biggest countries like Japan, Germany, Chinese Taipei or Taiwan, South Korea, and look at this, Malaysia. Wow, Malaysia not bad, See, Malaysia also contributes 7% of the total exports of semiconductor devices back in 2018. You see that actually after China, the percentage of the distribution is more or less very close to each other between Taiwan, Korea, South Korea, Malaysia, Germany, and so on and so forth. In fact, Malaysia export even more semiconductor devices than the United States back in 2018. Okay, then how about, after that, semiconductor devices can be passive, can be the components, and then you use it, after the processes, you package it into an integrated circuit. So Malaysia is also a very important player here. In fact, Malaysia is ranked number 6 in terms of the global exporter of semiconductor devices and number 5 of integrated circuits back in 2018. Now, I don't know about you, but I am extremely proud to be Malaysian, when I see statistics like this. But the biggest question here is this: knowing this, and if let's say if you have an investment portfolio for KLSE, don't you think that you got to have at least a substantial amount or at least a meaningful allocation for technology stocks, right? Does it make sense to you? Now, I know a lot of people, say Malaysia is all about oil, about construction, about plantation. Yeah, those are important, but don't forget, technology is actually really the heart of our manufacturing industry, right? Okay, so I hope that I convince you enough with this data. Of course, I'm not going to talk too much about this. So this is from MIDA. You can see all the international, the MNC, the multinational names here, as well as local players. I'm going to talk a little bit more about this later. Then when you talk about this, in fact, one of my favorite state in Malaysia, although I'm a Sarawakian, but my favorite state is really Penang. Why? Because every time I go to Penang, whether I'm flying down or I take the bridge, I drive through the bridge, right? I always look at the names which are popping out on at least the Bayan Lepas area. You see names like Jabil, Dell, Panasonic, Sony, Molex, Bosch, Renesas, Broadcom, and all device, so on and so forth. And these are the multinational companies that has found a home in Malaysia many years ago, and they started to build this ecosystem in Malaysia, and today we are enjoying the fruits of this investment many decades ago. And a lot of these listed companies are actually based in Penang, right? Okay, so as well, this is just a recap of what I said just now. For Malaysia, our E&E sector focus more on the OSAT assembly and test segment here. So as you can see, this segment consists of the OSAT players, include the names like Inari, Geopolitics, Carsen or Unison. Now they are one MPI. Then we've got the ATE or equipment suppliers like Elsoft, MMSV, Amulus, Vitrox, Pentamaster, Technovation, and then we got the material supplier like Foundpack. Then there's another segment which is not here called the EMS. EMS stands for electronic manufacturing suppliers. Basically, they are the ones that they are in charge of the end process where they package the end product before it ship out to the customers, right? So this, I'm not sure if you guys realize this, there is actually a FBM KLCI technology index, which is made up close to 100 companies. I made this table a couple years ago, so I think they should be still the same. So there is the reason why I highlighted some of the names in green, dark green and light green is because these are the tech companies or the semiconductor companies that Spiral Thinker, our group, is following very closely since the inception of our group. Most of us in the Spiral Thinker are engineers, and myself, I'm an engineer and by training and by profession before I quit my career completely. So naturally, we are more interested in technology space. That's why we've been following these companies since day one. Yeah. Now, of course, in the pandemic, in the coronavirus pandemic, no industry is safe from the downfall at the beginning of the year. If you track from the beginning of the year to the bottom, actually the technology index was down 45%. But as I mentioned, technology is an evergreen industry. It's a very semiconductor is going to be more and more important in the future. That's why we always believe any crisis is an opportunity. Now, just look at this from the bottom. Of course, this is measuring from the bottom to the top this year, which went up more than 150%. The question is not for you to fish at the bottom and sell at the top, right? I mean, anything in between, right? It could be 100%, it could be 80% upside, it could be 50%, right? Is it good for your portfolio? Of course it is, right? So this is just to show you that, anytime there's a crash in the market, which really affect the entire market, whether you have a good company or otherwise, right? There is always opportunity for us to look, right? Okay, so next, with the amount of time I have left, I'm going to talk a little bit about some of the case studies that we follow closely in KLSE. So I'm going to talk about, I think, 5 companies from the OSAT segment, from the ATE segment, and on the EMS segment. Okay, now first is this company called Unison. They bought, I think they merged with Carsen. Carsen is a subsidiary. So The reason why I like this company is because they're always very innovative. Their headquarters is in Ipoh, but they have manufacturing plants around the region. Ipoh, I think they have in Indonesia, Singapore, or even China. Now, why I like this company is because they are always investing into the future. Now, in the annual report every year, they will show you this technology roadmap that show the investors, what they have invested in. Now, fortunately or unfortunately, this is a very capital intensive industry. So for asset players, in order for them to grow, they have to put a lot of capital into the business, like to buy machines, to buy technologies, to hire engineers for them to deliver more advanced products to the customers. All right. And the specialty of Unison is what we call the WLSCP, which stands for wafer level system chip packaging. Now, what this means is, I want to take you back to this process here. Okay. Now, sorry, this is better. So traditionally, how things are being made is, from the wafer, you imprint you laser or you print the circuits into the wafer, then you cut the wafer into dies, and then you attach it to the package, right, to the device. Now, what WSCPs do is, instead of this process, actually the packaging is on the wafer itself. So you save a lot of processes here, which means what? You actually minimize the error rate as well along the way. So it is a more advanced way of packaging, and Unison has invested in this, I think, a few years ago, and they are actually running this production already, this technology already. Now, this was taken in their latest annual report, financial year 2019. So they're already investing in the future technologies, like 12-inch wafer bumping. So previously the wafer was bigger in size. Now they have a smaller wafer size in diameter is 12-inch. Then they invested a lot in EMI shielding. EMI stands for electronic magnetic interference, which is very important for communications in the segment. So by knowing where they invest the money in, you know what kind of industry they are targeting. All right. For example, the EMI is obviously to tackle the 5G segment, right? So on and so forth. Okay. Their major clients are Skyworks, Infineon, Qorvo. But lately they are 75% owned by this Huatian. Remember, from this chart here, Tianshui Huatian is one of the biggest top 10 OSAT players in the world, right? They are based in China, and they bought into 75% of Unison, I think, which was completed back in 2018, if I remember well. Okay, their dividend yield is about 1.6%, so not great, but okay. But their cash flow is pretty strong, about 6%, and they have a very strong cash position. Okay. Next, I will talk about one of my favorite stocks. In fact, this is my favorite OSAT players. By all means, disclaimer, this is not a stock pick recommendation. Inari has the largest market capitalization in the technology in this group of technology stocks. So Inari is the largest company by market capitalization here. As of I think 6th of October last week, they were valued at 7.5 billion ringgit Malaysia. The share price was 221. I think today, if I'm not mistaken, it went up to 250 or 249. But they are not cheap in a way, because they're commanding a PE ratio of 49, close to 50 times. But of course, if you compare to cloud players these days, this is not so crazy already, right? Now, what I like is actually a lot of tech companies in Malaysia, they are in net cash position. Okay, so what does Inari do? Inari actually focus a lot on the communication segment, which is related to 4G, 5G, so on and so forth. Not just the wireless application, they're also very much into the fiber optics. So fiber optics, you have other than the cable, other than fiber cable, you got to have, at the end of the cable, you've got these little things called the transceivers, the clips they call it, right? So this transceiver, what they do is they convert electronic signals into light. The light transmit in the fiber tube to the other end, which is then reconverted into electronic signals, which fed into the computing system. So this is what fiber optics transceiver does. Now, other than that, Inari also do a lot of smart display ICs, hermetic packaging as well. Hermetic packaging, most of the semiconductors, they are packaged using plastics. So hermetics use very special components like gold or gold-plated materials, which is meant for very high, very long-lasting applications like military usage, aerospace, EV, so on and so forth. Yeah. Now, of course, the biggest Inari is the biggest customer is Broadcom. I think 2 years ago they also got a new customer called Osram to focus on the fiber optics. But of course, Osram lately they have a lot of their own challenges. But the latest development is they are bought over by AMS, the biggest sensors company in the world. So I do see this as a big opportunity for Inari because now they have they can benefit from the growth of Osram. Although in the short term there may be a lot of challenges as the companies, after M&A, right, nothing is going to be smooth, right? There's going to be a lot of reprioritization, so on and so forth. But give it time, I believe Osram will be a very important client for Inari moving forward as well, other than Broadcom. All right. Now, next we're going to move on to the ATE players. I've got two favorite ATE players. There are a lot, okay? The fact that I don't talk about some of these companies does not mean that they are not good. It's just that in the limited time that I have, so I just show you what are those that we have been following closely and those that are my personal favorites. So one of my personal favorite is PentaMaster. I think if you are a shareholder of PentaMaster today, you should be very happy because the share price is like perpetually up. PentaMaster, they operate in two segments. First segment is the ATE. They also have the automated manufacturing solutions. They call it AMS, which they expect this to grow due to the more and more factories and more systems are being automated, right? So their products, their testing equipments are used for 3D sensing applications, automotives, and then the industrial robotics, so on and so forth. The major clients are MS, which I mentioned earlier on, the biggest sensors company in the world. They also supply the machines to Unison, to the other biggest OSAT groups like ASE, so on and so forth, right? Like Inari, they are not particularly cheap because they're commanding a PE ratio more than 40 times, but they are in a net cash position. Now, this is one of the reasons why I like tech companies and the reason why I love to visit Penang whenever I can to see my investments. Yeah. So other than PentaMaster, I also like this company. PentaMaster is I think the IPO many years ago. MI used to be called MI MI equipment. They recently renamed to MI Technovation. MI has a very visionary founder. His name is Mr. Orr. So Mr. Orr gave a presentation in the RHB Small Cap Jewel lately. So I captured this from his sharing. Basically, MI serves two segments, again, just like PentaMaster. First is the equipment side, and the other is the autobotics or the automation side. So MI serve the 5G space, IoT, high performance computing, artificial intelligence, industry, smart factories, so on and so forth. But one of the reasons why I really like IMI is because of their geographical revenue segmentation. As you can see on the bottom chart, 90% of the revenue derived from overseas, which means actually MI is basically an export company because only 10% of the revenue derived in onshore in Malaysia. So they supply to customers like Inari, Unison, Broadcom in Penang. But other than that, bulk of their revenue came from overseas like Korea, China, Taiwan, Singapore, so on and so forth, right? And interestingly, Mr. Orr shared the clientele in his presentation. As you can see, names like ASE, MCore, Spill, UTech, PTI. Does this look familiar to you? Right? If not, right, let me go back to a few slides. You see the top 10 largest OSAT players in the world: ASE, MCore, Spill, PTI. These are among the client of MI. So you can see how the potential of this company. Now again, a disclaimer, this is not a stock pick, but of course, what all these stocks that I mentioned here, I'm a shareholder, all right, so I have to tell you that I have vested interest in these companies, but they do come with a lot of merit of these companies. So if you're interested, it really, I think, is essential and it is beneficial for you to actually look deeper into this company that I shared. Now of course, again, like the rest, MI Technovation, they are also in a net cash position. They have a slightly higher PE ratio of more than 50 times, and their yields are pretty much much lower than the rest because of the perceived higher growth of this company than the rest. Okay, now I want to stress here that each of these tech companies or semiconductor companies in KLSE, although they are categorized as tech companies, but they have their own niche market, they have their own niche technology and their own niche clientele. So you can't really say that they are really apple to apple. You have to understand what is the DNA of this company for you to say, hey, yeah, this is the kind of company that I want to invest in. All right. If you just compare on surface, say company A is better than company B, I think it's not very fair and it's not very intuitive, because you really need to know what is the product that the product portfolio, as well as what kind of client or even technology segments that they serve. So there are a lot of great companies other than these, which I do not have the privilege to share with you today. Hopefully in the future, Shane Chun Sian will ask me back more times, then we can open up more topics of which is related to this technology space. Yeah. Now, last but not least, I'm only going to talk about one EMS player, which is VS Industry. Although VS Industry, they are not particularly in the semiconductor space, but they are categorized as an EMS player. Now, why I like this company is because they are very innovative. A couple years ago, they've got a couple of major clients, and one of them is being Dyson. And you know, Dyson, right, is very fancy, very modern vacuum cleaner and hair care products. What happened was back in 2018, they lost a big chunk of their orders, so the share price crashed. So the management learned a good lesson, not to rely too much on one or two big customers. So what they did after that is this: they went through a process to diversify their clientele. So from two major customers, today they've got 5 major customers now. The latest being Victory, which is like an electrostatic spraying tool for you to spray the disinfectant. Very, very useful during the COVID pandemic. And word has it that they are actually negotiating with a 6th customer base in US. So we don't know yet, but this to me are really exciting news, which I think is driving the share price up recently. So again, VS is they have a very efficient cash position, because again, like especially EMS is very, very capital intensive, so they got to be very efficient in how they manage their cash. They cannot keep too much cash, but they also need to conserve at least a manageable amount of cash for them to manage their working capital, right? So that's about it. You can look deeper into my slides later on. I'm sorry, because of time, I can't really talk into details. All right. Now, to wrap things up, so again, what kind of emerging technologies or future that we can look at, right? As I mentioned earlier, one of the literature that I follow very closely is this Gartner group. They publish their emerging technologies report every year. So this year, actually they color code these technology nodes very nicely. The light blue means technology that will come true in the next 2 to 5 years. Then dark blue is 5 to 10 years, and so on and so forth. Now the technology will go through this cycle from innovation trigger. That's normally the very exciting phase. Like AI these days, everything is about AI, right? So there's a lot of money poured into AI that drives the companies up. Then after that, there's a peak. Then only when it crashes, then the plateau is where is when the real players will stick behind. Just like what happened in the 2000 where after the dot-com bubble, a lot of technology or dot-com companies crash and then disappear from the face of the earth. But those who stayed behind, like Google, Microsoft, Facebook, Amazon, right? These are the real winners in that space. So the emerging technologies will also go through the same process. Okay, then you have to decide, based on the understanding and how you look at technology, right? Where are the particular segments to look at? Personally, I really like the ontologies and graph. Basically, this is like a mind mapping, and it has a lot to do with AI, how AI perceive the world. For example, AI, if you have an optical system, they look at this. How do they know this is a bottle? How do they know the yellow color is lemon, right? It is all based on this their artificial machine learning algorithms and database that they keep there, that they have inside, right? Then so on and so forth. So you can look at this chart. You can Google it for a higher resolution. I'm sure you can find this interesting as well. All right. Now, but will all the technologies happen in one shot? Not necessarily. This is based on my personal opinion and my understanding of technology. So I believe the chronology of technologies which is going to happen in the future, in the coming years, is going to be like this in chronological order. First, 5G needs to happen. Why? 5G is like a super highway. Now, if you have a truck, you have a lot of fast cars, but you do not have a good highway or highway that is wide or long enough, right? Then what's the point of the trucks or what's the point of your Ferraris, right? So the highway needs to be ready. In other words, the infrastructure needs to be there. Now, once the infrastructure is there and mature, then you can put a lot of components inside the actuators. Like you can put your cars, you can put trucks, you can put trailers, you can put Ferraris, you can put all your cars. These are the IoT phase already. Just now I talked about IoT, where initially they thought by 2020 50 billion devices will be connected. This has been pushed back a little bit, but I'm sure that it will happen eventually. Then with the IoT and 5G coming together, then is where they'll increase productivity. With smart meters, smart factories, right? This is where you drive the industrial revolution 4.0, 5.0, 6.0, even higher, right? Then at the end is where in the future technology is really coming about your AI, your autonomous vehicle, your quantum computing. That is where maybe Elon Musk will finally has his dream, to have a space travel to other planets, right? So that may happen, but I don't know when. Hopefully, I will still be around. Yeah. Um, then there are other issues that we need to take care of. So I think US-China trade war is one of them. We got to take care because this will basically divide the world into two camps. So the US camp and the China camp. So in a way, I feel that it's very sad that technology is being politicized, being used as a weapon, to contain or to fight against each other in the global arena. But again, as I mentioned, we always believe that crisis presents opportunities, challenges present opportunities. So you just got to be a bit intelligent and wise or smart to choose which side you want to side. But of course, to me, as an investor, I don't care who wins. If my capital is large enough, I would bet my money on both sides as well, so that whichever wins, my investment will still win. Yeah. Okay. Then of course with COVID pandemic, one cannot deny that one of the, I would say, positive things, although COVID is a very devastating thing, right? But one of the positive outcome of COVID pandemic, it accelerates digital transformation globally, not just in US, not just in developed countries, but even in Malaysia. Previously, companies may be, taking the sweet time to say, yeah, I know digitalization is very important, but I still need to run my business, so I can delay this. But with COVID now, people just woke up and say, oh my goodness, I cannot delay this anymore because I'm losing customers. So a lot of companies are going through this digital transformation, like working from home, so on and so forth. That's why Zoom the video conferencing came about. So there can be a lot of potentials for ICT opportunities, which is listed here as well. You can take a look. All right. But I'm going to end my presentation with this slide. Now, one of the biggest trend that I'm very interested and tracking very closely is actually you see that these big techs like Amazon, Tencent, Alibaba, so on and so forth, right? They're coming out with their own semiconductors and chips. Why? Because these are the biggest consumers of these advanced technologies, right? So they say, hey, in that case, why don't I own the technology as well? I develop these technologies with the people, with the suppliers, with the design houses. They own part of this technology. And because these platforms, these big techs, they are so big, they've got such huge bank account, right? They say, hey, I can just throw my money at you and you develop it. Then at the end of the day, I own part of this technology so that I can protect my business against my competitors. All right. You can see that Amazon is doing this. Amazon is developing cloud chips. Alibaba is doing the same thing. Tencent is doing the same thing, right? So I believe this is a space that we should look at, especially if you have investments in overseas. This is something that you cannot overlook because there's a lot of opportunities here. Okay. So with that, that ends my presentation. I hope I did not lose you along the way. I know that it can be very technical. Next, when I come back, I'll dive into a more specific topic, which relates to the 5G space, and there are a lot of interesting things happening there as well. So Shane, Chun Sian, if you are there, I'll hand over back
Yes,
to you.
I'm
Thanks a
here.
lot. Yep. Thank you.
Yeah, thank you so much, David. So let's give up for David, okay, for very wonderful sessions and in-depth analysis of for this session. Now, even though this is overview of the semiconductor sector, but I believe that you are now convinced why David is always my go-to person when it comes to technology sector. As any jargon I don't understand, and if I want to get his view on a certain stock, okay, I will just ask him. So now you're convinced, huh? Okay, so if you feel that now this is beneficial to you, or let us know in the comment if this session is helpful to you, so that we can organize more of these sessions for you. All right. So thank you very much.